Hi, I'm Jim Herries. I'm a geographer at Esri. Been there 26 years, 27 years, I don't know, something like that. I started in 1994, 1995, depending on who you ask. More about that later. I work as a geographer on a team called ArcGIS Living Atlas, where we put the software and data together to provision maps and layers to our user community. So for people who want to use GIS to study food or food insecurity or food deserts or food swamps, whatever you call it, whatever you prefer to call it, people like me try to figure out, well, what layers could I publish to help contribute to the conversation? Whatever you call food deserts or the topics related to them, this really is about understanding who has access to different kinds of food and what are the impacts of that access. As a geographer, I represent those who think about this issue from a spatial perspective. If I were a dietitian, I would be talking to you about the dietary aspects of this topic, the different kinds of food, the calories versus the quality versus preservatives and everything else. I'm not a dietitian. I'm a geographer, so bear with me for the next maybe 15 minutes while I kind of drill in on some of the important geographic characteristics I think are undervalued, underrepresented in people's analysis of this topic. And the reason it matters is because the things I'm talking about will help build an empathetic view, household by household, neighborhood by neighborhood, rather than a kind of cold, sterile database view of how we talk about these things. You'll see what I mean as we go along, I hope. Now, a real challenge with this topic is that people tend to extrapolate their own experiences about food when they hear the term food desert. When Jack Dangerman, our company president, found me outside the Esri Cafe in 2010, so it was 12 years ago, and he pointed at me and said, "What do you know about food deserts?" I said, "I don't know a thing." I really didn't. I'd never heard of the term. He said, "Well, go find out about it, and more importantly, find out what GIS can do to help." And he gave that charge to many people at Esri to try to contribute to the conversation. So I went off and started looking into it. And this is one of the first things I found out. I'd say the term food desert, what do you know about it? And almost 50% of the time, people would say, "What are you talking about? How can there be a food desert? There's food everywhere." And after a while, initially I thought, yeah, you're right. And then later I thought, wait, then why are we talking about this? Indeed, there must be a reason. Well, what it finds out is most of us tend to extrapolate our own experiences. When we hear about a topic, we try to relate to it. And if we can't, we kind of say, well, this is my world. And if it's different elsewhere, it's news to me. And that became sort of my challenge is, okay, well, it is different elsewhere. And I am going to make it news to you because it turns out there are food deserts and people are trying to express them. When someone says, "How can there be food deserts? There's food everywhere." There's really no empathy at all in that statement. And that's the real problem with a lot of topics like this, where if we want to really move the needle, we're going to have to recognize that people don't believe what's happening to begin with. So how can we overcome that? Well, a geographic approach is actually a very meaningful way for all of us to become empathetic to an entire community's experience. Just because it works one way at your apartment or household doesn't mean it's that way for everybody in the community. So let's enough chit chat. Let's kind of go through my most recent work on this topic, a story map called "Measure and Map Access to Food Grocery Stores," and it's taken from the perspective of people living in neighborhoods. So I worked hard in 2021 to create this simple measure of access to food. On this map, you see in red the locations of grocery stores, and areas in green surrounding them are within a 10-minute walk of at least one grocery store. So if you happen to live right in the heart of all these grocery stores, looks like you got about 4 or 5 options. If you happen to live right over here in any of this green area, you have one option. You have one walkable grocery store. So it's kind of a measure of competitiveness. It's kind of a measure of ease of access. And then for those in the blue areas, you need a car, or you need a bus pass, or a bicycle, or a friend with a car. Or maybe you need to live in group quarters where the food is provided. Or you need to live in group quarters where a shuttle bus will come and take you to the grocery store once in a while. But all the areas in blue are within a 10-minute drive of a grocery store. So these areas in white over here, part of the river, looks like a little oxbow along the river. These areas in white, you can't get to any grocery store in less than 10 minutes, right? It might be 11 minutes right here, and then 12 minutes, and then 40 minutes. So that was kind of the latest version of what I've been doing to kind of map grocery access. And after building this map in ArcGIS Pro using census data and locations of grocery stores, I wanted to make a tool available that anyone else could follow in that path and just substitute their own grocery stores in there. Use the same census data, but just substitute your own updated list of grocery stores you deem to be a source of good food, or it could be other stores. So if we look at this live map, here's Memphis. That's great, but y'all are somewhere else, aren't you? I'm going to type Pittsburgh, just, randomly. And here we are in Pittsburgh. And what this map is showing me is areas in green, again, accessible within a 10-minute walk. And the chart reflects for this map extent. Everything you see on the map is represented in this chart. So about 27% of the people in this map can walk to a grocery store. And a grocery store is here deemed as a source of good food. And if I zoom in, the map's going to update and the chart's going to update. If I zoom in again, I always want to say enhance and then have the map update like they do in the movies. But that'd be corny, wouldn't it? All right, so anyway, here's the Pittsburgh downtown area. And I understand this is pretty hilly on this side, and there's I understand the topography of Pittsburgh is actually quite interesting. I need to visit. So, very interesting pattern. I don't know if you had any expectation when I said I was going to zoom to Pittsburgh about walkable access to grocery stores. But whatever your expectation was, here's my version of reality using a data set that's available off the shelf and has not been personally verified by me for your city. So I don't know if this Giant Eagle is still open, or this Del Monte Foods, which I want to go there just to see if it's all cans. Okay, jokes aside, you can see that, like any map analysis, garbage in, garbage out applies. In this case, this is a high quality data set, points of interest data set, but it's not been verified by anyone local to say, yes, it represents 100% of the sources of good groceries in the city of Pittsburgh. That might be an opportunity for you all to consider doing a local survey, even if it's just of one neighborhood like the Oak Hill area, or what's that say, Shenley Heights right there, or the area around the university, Carnegie Mellon University. Okay, so having said that, this application works with data layers freely available in Living Atlas. In ArcGIS, if you just go to livingatlas.arcgis.com up here, just type livingatlas.arcgis.com, and then type in grocery access. Any GIS people listening to the sound of my voice might be pleased to know I've got all the components available here. I have a web map. You can just open it and start using it, and stuff it in a dashboard or put it in an application. I've got the origin destination access starter kit available. That's actually right here. This is an ArcGIS Pro project that does everything you need to swap in your points of interest, your store locations of good food, or maybe you would be interested in mapping out locations of all the bad food in town. I don't mean bad as in taste, I mean food you consider to be junk food or unhealthy food. You might inverse this analysis, right? And so it's well explained and documented, and actually this story map goes into, here you go. This story map goes into, if you go across the top, it tells you about the data and methodology up here. So if you just click on data, it'll tell you where the SafeGraph data comes from. That might be what you want to replace. It tells you importantly about the methodology, so it just kind of walks you through and a link to those tools. Others of you not inclined to do math or not inclined to do GIS, you might be interested in just kind of saying, I'd like to suggest that we put additional layers on the existing map. So you might take my map, as I did here, and go find, in this case I found in the city of Memphis, some additional data. I think I'll stay at this scale. These green dots and these magenta or pink dots, those are transit stops in the Memphis transit system. And so when you overlay this, that's a great geographic thing to do. It's a great way to ask a question. How does the transit system help or hinder access to grocery stores? Now, I don't think this is their complete set of transit stops for the entire city. I think, as I recall, the green ones are an existing set of transit stops, and the pink ones are planned. And so the question is, do these transit stops aid in access to grocery stores? Well, this last stop is near 2 grocery stores, but what if additional stops went up this road towards the northeast? Imagine if they had stops all along here. The access to grocery stores score for public transit would go dramatically up. And this proposed extension clearly reaches out and touches 1 grocery store, but maybe since there's 2 Krogers in the area, maybe Kroger would be interested in sponsoring a couple additional stops construction. It's good for their business. All right, so you don't always have to be a GIS gearhead like me to contribute ideas. So I want to make sure everybody feels like they have something to contribute here, because the fact is you do. All right, a little bit of background. These are slides I started in 2010, but I update them pretty much every year. I just don't update some of the graphics or cartography, so a little bit of it reflects the time period. When Jack Dangerman asked me to look into how GIS can help with this topic, these are the ways that I came up with. I saw evidence in the literature, the academic literature, and in some of the trades, that people were using GIS to map health issues like obesity and diabetes in their neighborhoods. They were looking to map behaviors and spending preferences, lifestyle preferences, consumption patterns. I made a map showing from the consumer expenditures data from the U.S. government, showing how much money do people spend on food at home, in other words, preparing food at home, and how much money do they spend on food away from home. And the patterns in cities, around cities, was just amazing. I couldn't believe it. I have that map somewhere. I'll try to dig that up so when we talk I can show that. And then you can map the different food options available. What do you think a source of good food is? Here I put the kernel. I think this is an actual satellite image. I think that's why I put this in here. Somebody actually did this on the ground. Anyway, you can map the options available. You can map food quality or prices. You could map travel costs. That has an effect on people's ability to get to good food. I saw a really good set of papers about mapping the advertising environment in neighborhoods, because that does influence people's purchasing patterns. But I was mostly interested in modeling and mapping access to food. And when I looked around, what I saw was some interesting stuff like this USDA example from 12 years ago, where they took 40,000 grocery stores. They drew a 1-mile ring around each grocery store. That's the simplest geographic, query you can use. And then they looked at population. They created a 1-kilometer population grid, and then they signified in these black outlines any low-income areas. And they concluded 2 to 7 million households had food access issues. I also found work by Mari Gallagher, who scored every census tract. And I love this idea because I was thinking in the same way. What if we scored every neighborhood based on its access to grocery stores? I mean, that would tell you something useful about that neighborhood. And then having that score on that neighborhood, you can then do some analysis about spending patterns or about health patterns. And maybe there's a correlation between their access scores and some of the outcomes or behaviors you're observing. So that's why I appreciated Mari Gallagher's work. Overlaid the neighborhoods. They used a half-mile ring from the center of each census tract. So what does that mean? What's that word centroid mean? Let's take an easy example. See where it says 33? Let's say that is a census tract. And right there at the center of it, we call that a centroid in the GIS business, just to do so. And anyway, if I've got that as the center, within a half mile of the center of that census tract, how many grocery stores did I find? So it's kind of a very coarse-grained analysis. It's not really empathetic to the people living there, because basically it says there might be 3,000 people living inside this polygon, but I'm just going to represent them as a single point. I'm going to draw a 1 half-mile ring around it. We're going to call it a day. That's an analysis. I was like, okay, well, I love the pattern. I just don't like the resolution of the data. I also found out something that surprised me, the term food desert. This quote from Angela Odoms-Young at UIC College of Applied Health Sciences found this quote in a paper. As a researcher, if food desert is something policymakers hear and want to do something about, I'm in support of it. But as a community member, it's another negative thing about the place where I live. It's not the need that brings in resources. There's got to be that and. There's a need and an economic opportunity. So that resonated with me because of all my GIS work with retailers, grocery chains like Albertsons and pharmacy chains like CVS, where I help them use GIS to optimize, their store locations, figure out their product mix that they needed to provide at that location, etc. I began to see food deserts as a similar problem. We can't just characterize neighborhoods with negative connotation. We also have to be looking for where's the missed opportunity to help or to create business, create profit, to create opportunity in all the forms that takes. I did run across some great maps in the city of New York. City planning, they did these maps by neighborhood of, on the left, health issues, diabetes and obesity. In the middle, behaviors, who eats fresh vegetables the previous day and who doesn't. Very simple maps to just get the concepts across. And then I tried to contribute something. This was my very first food desert map, just very simple, green or red. Sorry for any colorblind issues that you might haven't seen this, but I wasn't educated at the time about the need to address my green-red maps. Nonetheless, at the time, I scored every census block based on its access to grocery stores, and that was my first iteration of it. Lots of folks have done other things. John Duquesne at Philadelphia Inquirer did a great story tracking after the federal stimulus money was doled out to help corner stores add healthy food. He started tracking the information in this newspaper article. And I thought that was a great way to go. That local angle, someone making the effort to go check on things to see what the lay of the land looks like. That makes sense. I share this just for your reference. Factors in choosing food. You have to be, I like this funnel because at the end of the funnel you make a choice. But leading up to that funnel are all kinds of factors, one of which is distance or access to food. It does matter. So access is a more accurate and less misleading concept than food deserts when it comes to highlighting food inequalities. And you can see that pretty much in any map. If you just go get the grocery stores, here I put them in these white rectangles. And also I chose some fast food stores in nearby areas just to kind of help visualize the point that it's a competitive landscape. And when it comes to this choice pyramid, the landscape comes to bear. I know with my kids, when I have to drive home from picking them up at school at least twice a week, I am petitioned, can we go to Subway? It depends on what you get, right? That's how we've negotiated it. Because I know we do make an effort to buy food and bring it home. See, I'm extrapolating my experience as a way of relating with it. But in our methodology, we also have to look at the landscape a little more critically to say, wow, if you live in any of this area, there's no walkable access to a grocery store, but there's plenty of access to fast food joints along the way. How GIS models food access? Well, look, we know where the people are in terms of a database full of demographics. We've got it at a fine-grained resolution called census blocks. We know where the food is. You can either use off-the-shelf products like SafeGraph for your store locations, and or you can take that and go validate it, do some field verification, or maybe pick one particular segment of food like corner markets, or maybe super Walmarts, super Krogers, whatever they call them, to see what's available. And we know how people travel. People plus access plus food equals a map. And we can make that map available. This is the list of tools that I provided 10 years ago. I've now got it down in that pro package to just a very few steps. We also I want to encourage you to steer away from crow flight distance or rings, 1 mile ring, half-mile ring. This shows the difference between a ring in yellow around a store here on West Redlands Boulevard. And in green, this is the actual distance you can walk in 10 minutes on the road network. So you can walk down the street, make a right, and get this far just below the highway before you run out of your 10 minutes. Whereas if you walk straight west along West Redlands Boulevard, you will get to a full 1 mile in a 10-minute walk. But notice what happens above this interstate. This interstate is inhibiting the trade area for this store from a walkable perspective. So you don't want to be the person who does an analysis. North Redlands is a little lower economic status than South Redlands. And it's talked about that way. You don't want to be the person writing an analysis saying, yeah, we analyzed it, and this part of North Redlands is covered by these stores, when in fact the walkable analysis says only a tiny portion of all these census blocks in these little dots in North Redlands, only a tiny portion is accessible within 10 minutes. The observant among you will say, yeah, if you ran 11 minutes, you would have captured this one, and you'd probably captured this one. You are absolutely right. There is a sensitivity analysis that is worth considering doing. But overall, I just wanted to educate you that the error rate comparing crow flight distance, here simulated by a person, this is my cousin, being shot out of a cannon, that's crow flight. We're going to go in a relatively straight line, a certain distance. The distance between crow flight distance, example, from this house to this park is 0.6 miles as the crow flies. But in actual walkable distance, it's 1.2 miles. And this is a suburban context, so it's really bad in the suburban context. But as you see here in any kind of semi-urban context, it's also true that you get you get at least a 50% or higher error rate in terms of measure of distance. So think about that. If you're doing a regression analysis relating access and distance to some phenomena, you know going in, your distance could be, your measurement of distance, and therefore your measurement of access, could be off by 50% or 100% or more. Who wants to go into that equation with that kind of error rate if you can avoid it? And the good news is you can. The GIS lets you do these things. Also, the GIS lets you choose the level of census geography to work at. Here's a census tract. It's just 0.53 miles out of reach from a half, if you're using a half-mile crow flight as your cutoff, all of this census tract is out of reach. But if you go to block group, one of the block groups inside that census tract is within reach. And if you go to block, all of these blocks highlighted in yellow are within a half-mile crow flight, but only these blocks in the green area are within a half-mile or a 10-minute walk along the actual road network. See the Chicago River cutting through the middle of this, right? So these analyses ignore the Chicago River. They're not even on the map. It's not even on the map. Here it's on the map visually, and in terms of this, it shows up in the analytics. You can walk across this bridge and get to these census blocks. So instead of reaching what they want to reach 5,000. If this had been within reach, it'd be 5,182 people. There's only one block group within reach. It's 1,463 people. Crow flight distance to the blocks, there's 1,100 people. But if you factor the actual roads in and the fact that the Chicago River is, a thing, then only 84 people have access. So that's just a visual demonstration of what was done and the philosophy behind these measures of access. So this is what I did 10 years ago, and this is kind of what I repeated last year, taking all the census block centroids and all the supermarkets, doing a 10-minute score to kind of judge, wow, this is what it looked like back then. Whew, I was really into the red greens back then. This is what access looked like 10 years ago in my neck of the woods, Redlands. And there is a difference, just to drive it home. When you use blocks as your census blocks as your unit of analysis, this is what the map looks like. If you go to a bigger geography like block group, or tract would be even more big and blobby and worse. What you notice here is the census blocks respect, or the analysis, because it uses census blocks, it respects the reality that an interstate is a thing. If you switch to block groups, these centroids are far fewer in number, and the interstates don't come into play, which is not empathetic. That's not how the real world is experienced. When you use census blocks, you can also do things like characterize in red the count of people you estimate are living in poverty. And that enables you to make a map that clearly shows in red, these are the folks we would like to help the most. In green, the inverse story is true. These are the people living in poverty we are helping by having these stores available within a walkable distance. So there's both sides of that coin, you can tell. Oh, yeah, and just circling back, the USDA, remember, they estimated 2 to 7 million people underserved. Through this analysis, we estimated almost 3 times that number, 62 million underserved. So I look forward to talking to you soon. I think we have an hour-long time together coming up, and I'll be just really excited to talk to live human beings interested in a topic I also share interest in, and I'm really looking forward to it. I think I learned as much from these interactions as anything else. So thank you for the opportunity to chat and just share a little bit. Hope this wasn't too long or rambling. If it was, hit pause, go get a coffee, and then try it again. It'll be better the second time.